Hi guys, chapter 11. We are going to learn about the atomic nature of matter, atomic structure, and what makes up all the atoms. Okay, so just a little bit of history first. Alright, we have Aristotle and the Greeks, and then John Dalton, and then Robert Brown, all through the years, as you can see by the timeline here. All had ideas about atoms, but Brown actually kind of saw what they did. Didn't see them, but saw what they did. And here's a little video about Brownian motion. He was a botanist, and he was looking at plant cells under a microscope, and he saw these cells moving, but nothing was bumping into them to make them move. So he said there had to be some kind of invisible particles that were making them move. And that invisible particle is atoms. Right. Atoms, as you've probably heard throughout your education, they're incredibly tiny. You can't see them individually unless you have a really high-powered microscope. Alright, ion microscopes are the latest and greatest thing used by NIST and DC to research nanoscale measurements of atoms. Alright, atoms are plentiful, so numerous. It takes billions of atoms to make up the tiniest little piece of matter. They're always moving, whether in flux moving or just vibrating in place, they're always moving. Right? And they're ageless. It's impossible to tell how old an atom is. Alright? Now here's the structure. Here's the classic structure. Alright? This black circle in the center here, that's your nucleus. Everything that lives inside the nucleus is called a nucleotron. Alright, now there's two types of nucleotrons, as you can see here. These yellow ones are neutrons. These red ones are protons. Alright, and then outside the nucleus in this cloud-like structure, alright, this cloud surrounding your nucleus, is where your electrons live. Okay? Now what keeps that atom all together? Well, there's strong nuclear forces at work that holds that nucleus together. Alright, but what holds the electron cloud out there is basic force of attraction. Alright, you ever heard the old saying, opposites attract? Alright, that's so true in physics. Alright, if I flash back to this picture, alright, all these electrons out here, they have a negative charge. Right? All these protons in here, they have a positive charge. Alright, so these electrons are attracted to the protons, right? But these electrons are repulsed by one another, right? So what holds them in the cloud is their attraction to the protons, but what keeps them spread out in the cloud is their repulsion to each other. And that's how it works. And there's a little video for that. Okay? Well, that atomic structure and make up all of our elements, right? So depending on how the structure is, how many protons, how many neutrons, how the cloud of the electrons is made up, all that lends a hand to what element it is and how that element behaves. Okay, now if you see the word an elemental substance, that means it's composed of one kind of atom only. Alright, well, the lightest and most abundant element that we have is hydrogen. Right? There's about 115 known elements, right? 90 occur in nature, the others are produced in a laboratory and are unstable. Those are your radioactive sorts. Okay? Now all living things have these 5 elements in their composition, right? In some shape or form. Okay? Well, what makes oxygen oxygen? What makes an element what it is? Alright? Well, that has to do with, again, its structure, how it's made up. But here is your periodic table you've probably seen before. It's got all your atoms in there, right? All elements. Okay, and here's a little video on how to sort through that. Alright, but this is kind of a chemist's roadmap. It tells them what's where, how many protons it has, all that structure. So let's see how that works. Alright. Well, a periodic table, right, like we just saw, is arranged by atomic number. Right? That atomic number tells you how how many protons are in there. So you see these little numbers at the top, so 3, 4, 5, 6, that's the atomic number, right? You can see that on this blow up one I have here for nitrogen, right? The number at the top by itself, that's your atomic number, right? The big N is the symbol, then you have the word for the chemical name spelled out, so nitrogen. Then down here at the bottom you have the atomic weight. Alright, so that periodic table is classified by increasing number of protons. Okay? And that number of protons is what makes that atom what it is. Right? So take nitrogen here. It's got an atomic number of 7. That means it's got 7 protons. Well, if I add a proton to it, it's not going to be nitrogen anymore. Right? So proton makes it what it is. Now, if you have a balanced atom, right, that means the charges are balanced. That means you got just as many protons as you do electrons. So equal balanced, right? Equal charges, excuse me, balanced. Alright? Now this atomic weight here tells us something important too. That atomic weight is the sum of the protons and the neutrons that live in that nucleus. Okay? Now this far right column on your periodic table, right, that's a special set of gases. They're called the noble gases. And what makes them so special is in their electron cloud, it's full, right? So that means it's really hard to exchange an electron with another element, right? So they are this most stable, right? So that makes them special and unique. Alright, if an atom is not balanced, like I was meaning before, then it has a charge. If that's the case, it's called an ion. Alright, if you have more protons than electrons, that's a positive ion because protons are positive. If you have more electrons, electrons are negative, so that means you have a negative ion. Alright, now isotope is a little bit different. That means the number of neutrons is different than its normal state. It has the same type of behavior. It's not a different element, but it's an isotope of that element. Alright? How do we identify that isotope? Well, that atomic weight would be different. Okay? So if we flip back, see this atomic weight of 14? If I were to add an extra neutron to nitrogen, that atomic weight would be 15. If you were to look at your periodic table, you'd be like, wait a minute. That's supposed to be 14, not 15. What's going on here? And you go, ah, I have an isotope. Okay? Alright, and here's a couple of examples of isotopes you can study. Alright? Now we know that we have compounds, molecules, mixtures. We have combinations of these elements that make up everything that we use day to day. Okay? Now, when atoms of different elements bond, that's a compound. Right? Perfect example, table salt. Right? That's sodium and chlorine combined together. That's a compound. Now a molecule is formed when 2 or more atoms join together. Right? That means it could be atoms of the same type or atoms of a different type. Okay? Now all compounds are molecules, but not all molecules are compounds because you could have the same type of element. Compounds, they have to be different. A molecule, they can be different or the same type of element. Okay? Now, to make a compound or molecule takes a chemical reaction. Okay? That's how they're made. You can't just stick them together. Can't glue them together. Right? Some kind of chemical reaction's got to happen to make them combine and form their bonds. Alright? Now, a mixture is different. A mixture means no chemical bonding. You just put them in the pot and you stir them up. Alright? Air. The air we breathe is a perfect example. There are about 9 different gases that make up the air. They're not chemically bound. You know, we could separate them out if we had the means. They're just mixed in there. Okay? Now, to make these molecules and compounds, I told you we needed a chemical reaction. Okay? Well, chemical reactions involve energy. Alright? To unbond a molecule, pull them apart, that requires energy. Alright? Just think of it if you're trying to pull something apart yourself. It requires energy on your part. All right? The opposite of true is if we're putting them together. If we put them together, then they release energy. All right? I've got a couple of examples on there for you. All right? These are just other little tidbits for you. Interesting little facts they cover in your chapter. You won't be tested on them, but I thought it was some interesting reading. Okay? So be sure to read your text, look through these examples, and watch the videos to further your knowledge. All right? And enjoy learning about atoms.